Ever wondered why it is easier for a car to travel along a smooth road rather than a rocky path? It is all because of friction. Friction, in a nutshell, is basically the reason why your theoretical calculations for force, speed, or acceleration that has anything to do with surfaces will never be 100% accurate. Friction is always present between two surfaces, no matter how smooth it is. When the object is moving, friction is given by the equation Fk is equal to mu kn, wherein the force of kinetic friction is equal to the coefficient of kinetic friction multiplied to the object's normal force. The coefficient of friction is always dependent on the roughness or smoothness of the surface involved unless some substance is to be used to help increase or decrease it. Lubricants, for instance, are used to lower its value. This is mainly the reason as to why it's easier to slip when there is oil on the floor. On a completely different subject, baby powder is usually made of pulverized talc and starch, which is used for baby rashes, deodorizing purposes, and feminine cosmetic issues. Now, while its main use is an astringent, it is also notable how it can make surfaces smoother, thus making it a possible lubricant. For the purpose of finding out its effectiveness as a lubricant and the effect of lubricants as a whole in lowering the coefficient of static friction, an experiment was conducted using two blocks connected by a rope, one with mass m hanging and being held up by the other with mass capital M with a pulley. There were two setups. In the first one, no lubricant was applied. On the second, baby powder was wiped onto the horizontal surface where the block with mass capital M is. Then, the block with mass M would be released. Both setups had three parts. Three varying forces were applied on the block with mass capital M for each part. The different motions were recorded on camera and analyzed in Tracker. The coordinate plane and the calibration were set, both based on the block with mass capital M. The quantities for the x coordinate, y coordinate, velocity x, velocity y, and the acceleration were determined. Using Microsoft Excel, two graphs were created, one graph for each setup. The x-axis was given by the weight of the wooden block with mass capital M, divided by the difference between the two masses, while the y-axis was given by the acceleration, determined from Tracker. The slope of the graph is the coefficient of kinetic friction. With these, the two setups were compared. Now, if you ask, where does capital MG divided by capital M minus M come from? It can be explained through derivation. The whole setup can be illustrated in a free body diagram. With it, the forces acting on the x and y can be determined. This was used to derive the formulas and values that were to be plotted into the x and y axis of the graphs. For force along y in mass capital M, since no forces along y are acting on block with mass capital M, it can be assumed that weight is equal to normal force. Now, since the chord on mass m and mass capital M are the same, the accelerations are equal. Same goes for the tension. Therefore, the summation of all forces in the y-axis is equal to mg minus capital T, which is also equal to ma, and the summation of forces in the x-axis is equal to mu n minus capital T, which is also equal to capital Ma, since the equation n is equal to capital Mg for forces along x can also be written as summation of forces along x is equal to mu capital Mg minus capital T is equal to capital Ma. Using systems of linear equations on the formulas for forces on x and y, voila! This equation came out. Using y is equal to mx plus b, it can be determined that capital Mg divided by capital M minus m should be plotted on the x-axis, a on the y-axis, and mu is the slope of the graph. This graph 1, shows that the coefficient of friction is 0.1202. The first graph showed results without lubricants. This one does. This graph shows that the coefficient of friction is 0.0188, which is a smaller value than the first one. With this, it can be said that baby powder is an effective lubricant in lessening the coefficient of friction as proven by this experiment.